Hi, my name is Bailey Holsey, and my partner is Vishak Shukla. This is EE445L at UT Austin Embedded Systems. When we are making our final project, ours is called the AutoGyro. Here's our box, our enclosure for our PCB. So the AutoGyro is based on this idea called Galvanic Vestibular Stimulation, which is if you send a current through two electrodes to your brain on either right behind your ears, then this is my model head. It got chewed up by my dog a little bit, but if you put the electrodes right behind your ears, and then send a current of about 1 milliamps, it'll actually toggle your balance, so you'll feel like you're leaning to one side or the other, or depending on the direction of the current. So our idea was that if we could send that current through the brain in such a way that offsets the actual motion that you're experiencing when you're in like a plane or a boat, then we could correct for seasickness or motion sickness. So we got this accelerometer. I'll show you on the actual PCB that we printed. We've got an accelerometer here from SparkFun, with the breakout boards from SparkFun, and then we've got our output module here. So the way that we're controlling the level of the current is with the DAC, digital to audio or digital to analog converter, and then that voltage from the DAC goes through op amp, and then the op amp converts it to a current, and then the electrodes are hooked up through this headphone jack here. So with our PCB, we've got the core module right in the middle. We have a lot of logic analyzer probes. This is the power module where it can connect through USB, reset switch, LED. And then we actually had two of everything, even though it's not soldered all up correctly. But we had two output modules, DAC op amp, and then two SparkFun accelerometer modules. And then this box, excuse me, this box is, has some cutouts for some screws and the LCD screen. And then, excuse me, and then it has another one for the buttons. It's really primitive. It has some for the headphone jacks, and then one for this. There's another one for plugging in the device, and then one for the LED indicator on the battery. And so the battery kind of sits on top of there. It's got some stop blocks in here to hold it in place, and then this permanently plugs in to the USB of the board, and then you can plug in the whole system through this USB on the side, hence this hole. Unfortunately, we couldn't get our board to work, so I'll demonstrate here on the breadboard. So right now, and unfortunately, we couldn't get our accelerometer to work. So right now, all I have to demonstrate is the DAC output. So I've kind of got this UI here, and the current is nothing. Now that should say DAC, actually, the DAC output, and that corresponds to several microamps there. So if you push the button, I'm pushing the buttons here. If you push the button, it just increases the DAC output. It's a 12-bit DAC, so it goes up to 4096, but I set it to cap at 4000. So you can just change that level like this, and eventually, for future work, we hope to have some sort of measure of the current through our electrodes, and then display that current on here and how it adjusts the level. And then after that, we hope to not have the set point set by the buttons, but instead have it set by the accelerometer. So whichever position, like if I were to turn the accelerometer in one direction, then the set point would go up or down, and then the current would follow. So that's it. Thank you very much.